nice to be back. And it's actually, when I first came here, this building didn't even exist. So it's like, it's amazing to see. So I'm going to spend the next sort of 45, 50 minutes talking to you about this piece of software I've developed called Sonic Pi, which actually kind of had its roots at this conference. Because I remember going to one of the after parties and seeing the band that had been created and thinking, wouldn't it be like one of those kind of weird things where you think, wouldn't it be really cool if people could code the music? Surely that'd be a bit more appropriate for a programming language-orientated conference. And like sort of what, 12 years later, I'm starting to get to a point where that's actually now something I can do. But of course, it's really important to point out that anything that you think about is definitely not new. I have some pictures here, actually. There's this person here, Ada Lovelace. When she was working with Charles Babbage on those machines, they were working, the calculation machines, she was imagining that the systems that they were building could be used for musical ideas, musical expression beyond our imaginations. And so, yeah, none of the things that you do are new, but it's always interesting to think about what are the advantages and the changes you can add to that world. And so, I was going to skip straight into, I always talk a bit too much about the philosophy in the background, and I'm happy to do that later and answer questions. But I always wish when I watch my talks back, I think, I should have got to the fun bit straight away. So I'm going to go to the fun bit straight away. So this is the software. It was developed for schools to teach computer science. And in schools, I don't know if you've ever been to a school. Have any of you gone to a school to help out? Brilliant. That's 2, 3. Most of you should do this. It's really important. Schools are desperate for people with actual skills and knowledge to come and help. And a lot of the computer science teachers in schools haven't necessarily done a computer science degree at university, which is not the case for maths. Like how many maths teachers haven't done a maths degree, and how many physics teachers haven't done a physics degree? But computer science teachers, you'll find it's really common. So please go and support them. And when you go in, you'll find it's amazing how little time there is in schools. And so if you want to build something that's going to help a kid learn how to code, then you need to have something which you can go from nothing to something really quick. Normally, I would start with something like this. This is the first program you might write in Sonic Pi. I'm going to play the note 70. But I'll come back to this later, because it's way more fun just to skip ahead to the fun stuff. So here I've downloaded a whole folder of audio samples. So I went to a website and downloaded them. I bought the permissions to use these for performance, so it's important to make sure you get copyright. And these are just audio recordings for drum and bass samples. So I can click on one of these. If I go to the preview mode, probably, will it let me do that now? This one? There we are. Ooh, it's very loud, right? So there's a drum and bass sample. But what I can do is I can drag and copy this whole sample into Sonic Pi like this, doop, and it actually puts me the full path to that sample. So that's just the path on the file on the computer system to that sample. If I go into the high contrast mode, it might be easy to see. So there's the directory structure to that sample. I just write the word sample in front of it, and then you can hear that sample. Notice that it's quieter because Sonic Pi is adding a whole bunch of effects on the end of it. So, because kids, whenever you give them anything, they'll make it as loud as possible, right? So they'll put an amplitude 1,000,000. So this system will actually stop that from happening. So that's already a win. So hopefully the people upstairs are happier that the system's making the sound rather than the macOS. So there we go. So this is the point where you can play any pre-recorded sound. You can go from 0 to something interesting with one line of code. Now, that's fairly annoying because if I want to keep dragging them across, if I want to play this one, I've got to drag it across. So what actually I can do, which is really fun, is just drag the directory across. If I drag the directory across to like that, then I can play the directory. What? How does that work? So when you pass Sonic Pi a directory of samples, it actually goes, oh, okay, that's a directory. I know what that is. It's a container of possible samples. I'm going to go and look inside there, find all the samples, and then order them alphabetically and play the first one. So this now, if I've got a whole directory of samples which are related, it's pretty cool. I can now use indexing to work through each of these samples, and I can then play them one after other. So that's pretty fun. I can also do substring matching, and I can also put regular expressions in there if I want to, but usually the indexes are totally fine. So this is cool, right? So now I've got this ability to play these samples, and I'm going to show you how to make this into more of a track as we're going along. But at this point, we can teach functions, we can teach arguments, we can teach options, the fact that we can actually add these like integers on the end and work through these samples. And you can imagine a class having a sample pack of music of their culture or the style that they like, and that maybe they can choose, like, I want to do mine with drum and bass, I want to do mine with classical music, I want to do mine with jazz, and they could be instantly working with the style of music they like. But at this point, you can do lots of fun stuff. So I can like change the rates of this. Now make more of a downbeat sample. It's playing it at half speed, right? It's pretty fun. Yeah. Or I can like go a bit crazy and super fast. Or I can do something like this. What do you think this is going to do? Reverse. Yes, good question. Good answer. Oh, no, if I make a mistake, it's not. So you get all sorts of interesting things. Now, one thing that I noticed a lot of people doing, wanting to do, is to make interesting sounds where, because a lot of the original artists are working with these kind of samples in the 80s and 90s, they used like these magical scissors that could chop up the audio, and then they could reorganize the audio in different orders. And a lot of drum and bass and electronic dance music was exactly this. And so I wanted to make sure that this was possible. And the critical problem, though, in schools is that schools, the teachers are very, or certainly in the UK, careful to make sure that everything fits into the curriculum. And so, obviously, drum and bass is not on the computer science curriculum, right? Nor is playing things at half speed. But obviously, the idea of modifying a function certainly could be. But often people will ask really interesting musical questions. And so the whole idea of Sonic Pi has been really about finding ways to answer those questions with interesting and useful answers to give the children expressive, creative control over the sounds they want to make, but doesn't hinder or obstruct the teaching of the core computer science. And so, yeah, I was thinking about how lots of ideas, and I'll explain a few of these. But one of them is like to do this magic sample snipping. So, how this idea, it took me a while to think about it, but it's actually really, really simple once you've thought about it, is to treat the sample as, I can't type, on set, as an array. And I can work through each individual drum hit. So it's doing feature detection on the audio, it's finding all the drum hits, and then caching those time points, and then now I'm able to index through. So what's really fun now is I can actually go one step further and do like some sort of like a control structure called a loop. I can sleep for a short amount of time, and I can play that same drum every time, or I can play like this one, or I can play this one. That's a lambda function, which will play me a random drum sample. So we're getting interesting places, right, already? Right? So you can start to imagine how we can take this. Now, what's really fun is that kids do this, right? They love it, and then they'll do something else. They're right. Let's just comment this out, and let's. So these drum and bass samples are at 174 BPM. So let's specify that BPM 174, and let's do another loop, and let's do sample. And actually, rather than specify the sample here, let's just make a variable. So now we can say sample DNB 2 sleep for, I don't know, 60, let's go 32. Right, so that's that sample now in a loop. And maybe let's go for the bass one. Was there a bass one, wasn't there? Yeah, right. So let's play the drums at the same time as the bass. Now this is a question this is something that a control structure, an example program that I saw time and time again by kids just after a couple of hours of playing. Once you taught them loops, they're like, okay, I can do a loop for bass, I can do a loop for drums, and they were playing at the same time. They're like, oh, well, where are the drums? So this is an interesting interview question. If you want to work for Sonic Pi Limited, then you need to be able to answer this question. Why can't we hear the drums? They were working perfectly fine before, and I haven't changed the code, except for using the variable, of course. That's a simple substitution. Why can't we hear the drums? Well, it's because it's a sequential program. And the code starts at the top, gets into that first loop, which is an infinite black hole for programs, and stays there and loops there forever, right? And so it never gets to the second loop, ever. And so we can test this hypothesis by simply swapping the order of these loops, and hopefully we should hear the drums and not the bass. Oh yeah, it's going super fast, but we increase the speed. Let's go. maybe like even slower. Right, so we can only hear the drums and we can't hear that bass because of the fact that it's a single-threaded application, single-threaded program. And so at the time I was working with the schools, it was really cool because it was all very new and exciting, and Sonic Pi only did a very small, simple set of things, and I would work with the teacher and we would talk about what we were going to teach the next lesson, and then I would then develop the features of Sonic Pi to enable that lesson to happen. And then we'd teach it, and then we'd have a retrospective, figure out what worked, what didn't work, and then we'd repeat the cycle for every week for about 2 months. And so this was an example where I went to the teacher and said, oh, the kids, they want to learn concurrency, and so they can play the drum at the same time the bass. I'm pretty sure I can add that. It'd be really fun for them to do that. And the teacher said, sounds great. Is it on the curriculum? I'm like, okay, so on the curriculum we've got algorithms, data structures, conditionals, variables, yada, yada, yada. No concurrency, of course. And so I said, no, it's not on the curriculum. And the teacher said, sorry, we can't do that. So the girl who put her hand up saying how to play the drums at the same time as the bass had to go to her and say to her, I'm really sorry, no. But if you really, really want to do it, you have to wait till you're 18. Because when you're 18, then you go to university and they'll teach it to you then, right? And it sounds silly, but it was tragic because at that point I said that to that girl, and I said it to many of the kids because obviously there's an answer that you can't do this. They switched off immediately. They looked out the window, like, what kind of rubbish piece of software for music doesn't let me play the drum at the same time as the bass? Like, this is not a viable thing. This is not interesting for me. And that was the thing that really got me to think about what I was actually doing, the goal of the project. Because the remit of the project I was working on at the time was to develop some software to help children learn how to code. But actually, I discovered that I feel and I believe that's not the hard problem. It's easy to build, loads of different ways to teach kids how to code. The hard part is how do you get their interest? How do you maintain their engagement? How do you get them to want to do it? And if you've got them already asking questions like this, how do I play the drum at the same time as the bass, which wasn't on the list of things to do in the class, you've got them. You've got their attention. And they're asking things which are meaningful to them, which is unbelievably cool. You better be sure you've got answers. Because if you say no, they're off. And so this is a problem for me. And so if I had done the sensible, correct, professional thing, which is I've got my remit, I've got the thing I've got to develop, and concurrency's not on that, so I'm not going to do that, I'm pretty sure I wouldn't be here talking to you 10 years later. So I did what everyone sensible should do, is I broke the rules and thought about how could I actually teach concurrency, but in a way that the kids don't realize they're learning it, and certainly teachers have no idea they're teaching concurrency. So I invented a new kind of loop. It's called a live loop. And so it sounds cooler already. And they need to have names. So this is the drums, and this is the bass. And so by just saying in Sonic Pi, the loops are called live loops, teachers don't realize this. They have the same property. If I just play one of these on its own, it works exactly the same as a loop, no difference. Just happens to have a name. But if I play them both, it's not very loud. Let's make this louder. That's be 4. Oh, amplitude. Let's go 3. I'm playing at the same time, right? And so this is fun. So the kids are getting the drum same like the bass. They don't even have to ask the question anymore. It just works as they expect it to work. But this also gives a new opportunity because whilst this is playing, I can change the sample live. So this is fun, right? So this is not concurrency as you know it. So concurrency is multiple things running simultaneously at the same time, right? So that's already hard, and it's actually not. Concurrency is really easy. It's coordinating the concurrency, sharing data across the threads, making sure that this job is done before that job is done. That's the hard bit, but I'm not doing any of that here. At least not explicitly. There's a ton of it behind the scenes, but you don't need to think about that. But this is not enough, because if you imagine a band that's, like, unless it's a free jazz band, right? If you've got a free jazz band where the people in the band can do whatever they want, not even looking at each other, like completely staring into the stars, that's fine, right? That's concurrency. Those band members are just playing at the same time. But they're not necessarily playing in time with each other. But often that's what you want. And so concurrency the semantics of concurrency don't typically give you that. They just give you at the same time, not in time. But did you notice that these threads are in time? So there's a lot of work to make this possible in a way that doesn't drift and works across multiple operating systems, and it'll keep playing in time for as long as the computer's running, which is huge fun, and also allows you to hot swap the code as it's running, which is where the whole idea of live coding comes into play, because as I'm performing, I'm able to change and manipulate this. And this is the next important thing to talk about in terms of engagement, because when the early days of the UK's computer science curriculum, they asked old white guys with beards, typically, what got you excited about programming? Because we need to figure out how to get the kids engaged. This is the problem. And so these people went, ooh, yeah, sorting algorithms. Yeah. No joke. So they made schemes of work, like these lesson plans, that had names like, have fun with sorting. Like, who has fun with sorting? Another one was, I read, was give binary a try. Because obviously, it's like drugs or something. Once you've tried binary, you're never going to go back. It's just crazy. So that for me, again, this is the big problem. How do you get the kids excited? What do you do? And I think something like this is way more interesting. Let's find this picture. On my computer. Where are we? Let's go for this. So this, if you say to the kids, hey, would you like to be the DJ on that stage? That's going to be a lot more exciting, not to everybody, but to more of them, I would guess, than do you want to do sorting, right? And this here, performing, is a lady called DJ Dave. She's in New York, and she's using my system, Sonic Pi, to perform to this audience. And this is real, this is credible, this is actually something that people are doing and is natural pathway, and then the people in this audience, they're seeing a professional programmer. That professional programmer is not making Java server applets, although none of you are anymore, I guess, or Java service beans. No, that's too Kafka. They're not using Kafka. They're actually seeing a professional programmer who's live coding with concurrent algorithms on stage, and she heard the programs she's writing are being modified every 5 seconds, 20 seconds, right? Really exciting, innovative stuff. And so when they see that, they're seeing a musician. And they're going, what is she playing? What is that stuff? I want to do that. And that, for me, I think, is a much more exciting way to tackle the problem of how do we motivate that next generation of programmers. And I'm sure some people in that audience now will be thinking about live coding and practicing and wanting to be on stage that next year or the year after. I mean, I think that if someone like Taylor Swift, for example, were to live code her next track, we'd have 1 million young programmers tomorrow. And I think that's way more exciting than Bill Gates telling everyone we need more programmers to make more enterprise developers. Right? Because you're cool, right, enterprise developers, but actually it's like saying that the only valuable use of written language is for legal documents. Would you like to live in that world? No. There'll be no poems, no stories, no shopping lists, no text messages to your friends. It's all legal documents. And currently, in the programming world, most of programming is used to make business apps. That's pretty unfortunate, isn't it? That's pretty depressing. Because we all know how amazingly creative programming is. How wonderful it is as a tool for human expression. That you can literally come up with amazing ideas, and if you had the budget and the time, that's where the business bit comes in, you could make those things into reality. And I'm sure all of you have 1 million cool things you wish you could build, rather than build the next banking platform, or rather than build the next telephone communication system, or whatever it is you're working on. And not to say you shouldn't be doing that, because of course it's great, it's good. I'm sure if you're a plumber, you've got to go and plumb in all the hotels, but you'd rather be doing some bespoke, interesting, weird plumbing in some interesting house, of course. But I think there's a ton of interesting ways that computer science could be used that's beyond where we currently use it. And I think these people in this audience might be the generation to explore that. And it's not necessarily something that's going to make the money, but it might actually allow them to express themselves in new ways. And I think that's really important. And I think that comes again to why I think computer science is important to teach at schools. I don't think it's important to teach at schools because we're going to generate that next generation of professional programmers. I just think that's a ridiculous concept. You don't teach sports at school so that everyone could be professional sports people. Some of them might, sure. But there's so much more value to sports that's beyond only focusing on, like, you can play professional football, you can play professional hockey, we're going to focus on you guys. No, it's everyone needs to do running around and coordination and exercise and team building and communication and all the good stuff that comes from just playing a simple sports game. I think that programming also has lots of opportunities for creative thinking, computational thinking, if it's a term you like or not, but algorithmic thinking, problem solving, deconstruction, all this kind of cool stuff that we do, we can apply to lots of different places. And I think that's why we should teach this at schools. And it should be really about allowing people to express themselves in new ways and to interact and to work with the environment and the world that we're in more
Sam,
effectively. Yes.
Can you give us a success story with children when it worked?
Can I give you a success story with children when it worked? Well, so being able to do this was good. I mean, I guess probably the most visible success story was there was a set of schools that were working together in London, and they were in the music departments, and a lot of them were deprived schools that were struggling to get their kids to do anything musical. There was a bunch of money from the Arts Council in the UK to pay for all these schools to make bands, so they made wind bands and guitar bands and choirs and orchestras and drumming circles. And they also paid for a composer to compose a new piece of music for them all to perform together. And then they brought them all together to the Royal Albert Hall. And so I have a picture of that, actually. Where is it? It's here. Here we go. And of course, one aspect of that was Sonic Pi and live coding. And so we had our quartet of live coders playing alongside tons of all the traditional instruments. And you can bet the kids that I saw them asking, like, how come you get to play the synthesizers? Saying to the kids that are working in my quartet. So there was definitely some envy about what's going on. But here's a good example of where Sonic Pi has actually been... it's weird, because if I go to a school and talk to computer science teachers, it's a no-brainer, typically. They're all for anything that can get kids excited. They typically have more political issues and constraints that might be a barrier rather than the interest and the enthusiasm. Whereas the music people, typically often, there's so much gatekeeperiness that a lot of the actual elderly people working on this project were saying to me things like, that's not real music. Like, really? Like, did you not hear the syncopation and interesting polyrhythms and like the mathematical... Anyway, for some reason there's a lot of difficulty in communicating to musicians, a lot of musicians, that this is actually real music. But there must have been a time when the piano was created, or the harpsichord, someone wheeled in this big, massive object into the room and said, look at this, it's a new kind of instrument. And of course, then people were traditionally holding the violins, playing whatever it is, lutes, and they had their fingers on the strings, and they were touching the strings and playing the strings directly, physically. And here was an object that you didn't touch the strings. That was actually a mechanical object. There was levers and pulleys. And so it's like, you're not touching the real strings, that's not real music. So I think that there's always going to be some pushback when new technology comes along. But the cool thing about live coding, I mean, I can talk this all day, is that not only are you treating the code as an instrument, but the code is also a composition. So you're actually live composing as well as performing. And so you're taking these traditional things that would be very separate, like the composer is traditionally very separate from the composition, is traditionally very separate from the instrument. And here we actually can combine them in all sorts of interesting different ways that we couldn't before. And that gives lots of opportunities for interesting musical exploration as well. So, but anyway, that's the there. Does this make any sense? So, anyone? I've got any questions at this point? Or shall I just carry on talking about stuff? How long have I got?
I can give you the microphone if you have a question.
Any questions yet?
Yeah, let's say you want to write a score like in traditional music. So live coding does not really allow you to do that. So how would you handle that situation where you want to?
It's a very bold claim.
Yeah, I know. Yeah. Well,
so you say live coding doesn't let you make a score?
Not really. That's not what I'm saying. What I'm saying is, let's say you want to replay the exact same thing like old school musicians want to do. Would you be able to do that? Would you be able to keep versions of your stuff and see how they evolve over time? No, I'm not only talking about that. That's not really what I'm talking about. What I'm talking about is that, let's say you want to like let people play in live code, and then you want to do the exact same music again.
Oh, sure, that's a good question. So that's really about repeatability.
Yeah, kind of, yeah.
Yeah,
Or like
so-
scores in general, like something like scores in general.
Yeah, I mean, I don't quite understand what your question is, but in terms of repeatability, this is the critical one. So if I do like 7 times do like some iteration, and I play like some scale E3 minor pentatonic, and I choose a random note from here, and but I actually not rather than playing them all at the same time, I wait a small amount of time between each note. And there we are. Maybe I go a bit higher. And play it again. And play it again. So even though it's using randomization, actually it's deterministic. So this Sonic Pi is designed by default as deterministic behavior, and this is across threads. And so the cool thing about this is I can apply this to the drum break, so I can like play like the sample loop Amen and do the onset trick. And here's my drum break, and I can cut and paste that. You can take a photo of this, you can download Sonic Pi tonight, go to your hotel room, write the same code, and you will hear exactly the same drum break. And this is important to be able to collaborate in terms of compositions, in terms of snippets of code. So I can use algorithms to describe some interesting musical element and then paste it somewhere else and have it repeat. Or I can explore something in my studio and then go and perform it on stage. You might talk about, well, actually, I don't want that one. I want other random choices. Of course, then you can use a random seed and you can change the seed. Oh, actually, that's resetting it every single time, so that's not going to work. Let's do it first. A different one. So you keep playing with that until it sounds good. Often artists will say to me, well, that's not cool. You know, I like my stuff to be different every time. And it's like, you don't actually. Oh, I do. No, you don't. Oh, I do. And this is the problem. Like, they don't see actually that if you have a deterministic system, then you can make it non-deterministic really trivially. If you have a non-deterministic system, you can't easily make it deterministic. And so I could set the random seed to be the time of day, and then it's now a non-deterministic system as they want, where as long as it's not the same time of day every time they press the run button, it's going to be different. But actually, it's really nice to have these properties. And these properties work across threads, even though so I've had to implement my own random stream to make this possible. But yeah, then you were talking about versioning. So that actually, one of the features I've been working on behind the scenes is every time I press the run button, it creates a local Git commit to the local Git repository and stores a history of all the runs, so you can see all that. I haven't yet found an interesting and useful way to work with that yet, but that's certainly definitely possible and something that's very interesting to consider. The fact that your code is versioned across. So, and then maybe you sort of alluded to the fact that live coding isn't composition. And maybe you're observing the fact that I'm working with very simple things and modifying that through time. And maybe for you, a composition is a static entity rather than a dynamic entity. But maybe, yeah. But obviously, you could imagine writing your code as a long script, starting at the top and working its way down. And it could be as long as you wanted to, and that's your composition. And you just press play, and it'll play its thing. So you can work in those two different approaches of Sonic Pi. Either composition mode, as I would call it, where you're writing a long script, or performance mode, where you're working with these live loops, and you're hot-swapping them all the time, and keeping the tunes going dynamically and working with it like that. Does that answer your question, or did I miss something out?
No, like versioning was really my question.
Versioning was the question. Great, I got there on the end. Right, okay, cool. Any more questions at this point? Or shall I just carry on talking about what you can do? I mean, are you more interested in the history and philosophy, or what cool code bits you can write? History and philosophy, put your hands up. Cool code bits, put your hand up. Right, cool code bits, it is, right. So, one thing that kids asked for a lot of times was, I want to be able to do that, but I want it to sound like it's in a big room, right? So that's reverb. Now, with these traditional programming languages for music, you'd have to do something like this. You have to kind of like make a reverb with some sort of constructor or something like this, right? Or a function which would generate a reverb. And then once you've got the reverb, you then have to find a way of like piping it. Let's do like the Haskell style. Pipe it into reverb. And that might work, right? So somehow I've got this fancy operator which takes the output of the audio and pipes it to R, which is my reverb. But then I've got to find some way, when I know it's finished, of close down the reverb or shut down. like this, right? And so this is what you have to do. But this is to teach this in a class is a lot. You've got to teach variables, you've got to teach constructors or initiator functions. You've got to teach them with operator about piping or something. You've got to teach about the fact that they have to garbage collect this R, or because if they put it in a loop, whether they're like a live loop and they just constantly make new R's, suddenly you're going to run out of resources. Basically, it's like going to the the guitar shop and buying a reverb pedal, plugging it into your guitar, and then going to the shop and buying another one and another one and another one, and soon you run out of money or space. And in computing, you don't have money or space, you've got time and space. They're your two options. So this is like, but I wanted the kids to be able to do the reverb, but it's the same kind of problem. How do I teach the reverb or enable them to express themselves with different interesting effects, but not interfere or hinder the computer science lessons, right? Or require advanced computer science. Like if you ever go into school and try and teach variables, my goodness, they are complicated. You might not think they are, but they're one of the hardest bits. So, but whereas lexical closures, they're actually quite easy. Kids can understand that. They can understand putting blocks around things and doing this. Oh, I've got two do's. Make room size 1. Right? Because when they often use programming language like Scratch, which are building block things, and they are just lexical closures. Scratch is just Lisp, but rather than parentheses, because I have all these programmers. Who likes Lisps here? Oh, great. Are you all my friends? Hello. Well, let's go for the pub later. People go, no Lisps, because the parentheses are everywhere. But actually, there are more parentheses in a Java piece of code than there are in a Lisp piece of code, typically. They're just in a different place, typically together. But anyway, the kids use this language called Scratch, which has colored blocks instead of parentheses. And they will nest things like this very, very easily, no problem at all. And they can see that the 7.times bit is inside the reverb, therefore that's going to work. And we've got a clear starting point of the reverb and finishing point of the reverb, which allows me as the programmer to actually do that initiation, that R equals reverb.new equivalent, and to do the shutdown at the end, and to do the piping internally, all automatically, so the kids don't need to think about that. And that was actually one of the trickiest bits of code I've ever written, because you can actually put threads in here. You can track and trace all of the ways these things can create it. It gets really, really messy very quickly. But this is fun. And I can then change this into different samples. I can like bit crush it. I can the room doesn't work for this one, but there's like, where are we? Like, no. What was it? It was bits. Let's go for 8-bit. 4-bit. Lowering the quality of the audio, right? So there's a bunch of these effects inside Sonic Pi. And oh yeah, I should mention that there's a full tutorial built in, so everything I'm showing you and loads more is all in there, translated to many, many different languages. If it's not completely translated to your natural language, please do get involved with crowdsourcing the translations so that the kids in your schools will be able to read it in their native language. And there's a list of all the effects. So here's all the effects down the left-hand side that you can be working with. So Bit Crusher is this one here, and you can see that it's got 1, 2, 3, 4, 5, 6, 7 different controls to manipulate, to change. So it's like a guitar effects pedal with 7 knobs to twiddle. But those knobs have names, and you pass them numbers. Yeah, a lot of fun. What else? Like Echo would be a good one to play with. Yeah, and you can change like it's the phase time. So if I go for 0.125 divided by 2, play around with these kinds of things, right? So it's super fun. This all works by the audio synthesis is generated by a system called SuperCollider. So as I have a PDF somewhere on my computer, which will explain to you how it works. Let's go view full screen. Is it window full screen? How do I make it go full screen that way, like the shortcuts? So the way it works, I have this language server implemented a language called Ruby. Oh, it's actually doing it automatically for me. I don't want that. Stop it. It's actually it's got this thing called SuperCollider synthesizer, which is like an Nginx for audio. It's like a super cool, low latency, very powerful audio synthesis engine that has a network API. So you send messages from whatever programming language or environment to that, that synthesizer. And as long as you send the right kind of messages, it will make sounds. Super cool. And this uses a protocol called Open Sound Control, OSC. OSC is a very simple binary network packaging mechanism that has one really cool property which allows you to timestamp the OSC messages with very high resolution timestamps. And SuperCollider has a scheduler which will then honor those timestamps. So you ahead of time say, at time t, play this synthesizer. At time t, create me the reverb effect. At time t plus delta, route the audio into this, close this. So all the kind of messages you can schedule slightly ahead of time with these very, very clear timestamps, which means that if your programming language you're sending the stuff from has things like a stop the world garbage collection happening, which obviously are going to completely mess up your timing, that's not a problem as long as you schedule your messages ahead further than the maximum GC pause. So if you're doing this from like Java or something, then that'll be a similar kind of issue. If you're doing it from Erlang, no problem at all. And that's the future, I'll mention this. But, so yes, that's how that works. And then I've been slowly adding bits on. So there's for the schools, I had to have the GUI, so that's the C++ app, which also talks over the network. So it's kind of like weirdly small mini microservices, although that's obviously there's no Kubernetes or like things orchestrating this. And then there's no containers. They're just processes which are running, which talk to each other. And then I added ability to talk to the external world. So this is another thing I wanted to be able to do. So I've shown you how you can make sounds and play with the sounds and add effects and stuff. That's a lot of fun. But it's really nice to be able to trigger external synthesizers. If you've got a really fancy, expensive £10,000 synthesizer that's got this cool cable that you can connect to it called a MIDI cable, then you can send messages to that synthesizer to trigger its sounds. And so Sonic Pi now can talk MIDI naturally using this, again, a scheduler written in Erlang. And that was written by the late Joe Armstrong. He got involved with the project a few years ago. And we can also send network messages, which is super fun. But more recently, I've moved to Elixir for that part of the code, which is a really cool language built on top of the Beam. And I've integrated these things together. I've got this MIDI stuff now as a C++, what's called a native interface, NIF. And then this link thing, which is super fun, which lets you sit with a bunch of friends on the same local network and share the metronome across. So now you can do jamming together in time, which is super fun. So my sort of dastardly plan is to turn these like boring classrooms of beige PCs into a nightclub, into a disco where the kids can make techno music. Because they're all networked together, they're able to share the BPM. And the cool thing is if one person increases or decreases the BPM, it does it for everybody. So everyone stays in sync up and down. And links are a really cool technology that was invented by a company called Ableton. Ableton Link. There we are. And if the network works, you can see that it tells you how it works, but there's a list of products that support Link. So you can obviously use this for 2 Sonic Pis to talk to each other, or 3 or 4 or 5, or however many connected on the network. But there's now 235 different apps, pieces of hardware, iPhone apps, professional music software, professional DJ software that all work with this Link stuff, which is now the pictures aren't working. But they can all talk and work in synchronicity with Sonic Pi, which is super cool. So yeah, I'm excited about that. So that's what we added here. Let's go back to the pictures. Where is my? Did I lose it? Let's open it up again. There. But the latest thing I've been working on is to turn Sonic Pi into its own version of Electron, which means I've embedded a web server and a web browser into the software. Why would you do that? Well, there's loads of cool web technologies that I can start to play with. It'd be much faster to iterate and to develop these things. There'd be a much broader audience of developers who can get involved and help. There's tons of JavaScript developers. And it's just way more easy to iterate. Every time I wanted to make a change to the GUI, I have to change some C++, recompile the whole thing, it'll take a few minutes, see the observation that it's not what I wanted, change a few things, take a few minutes. Now I've got this really nice web developer experience where I can just change a thing, press save, and boom, there it is on my GUI immediately. So it's much faster to play with. Which then means I've been able to start to experiment with visualization software. So inside Sonic Pi, I've got some visualizations. So this is the example of this running. So this is a web browser, Chrome-based web browser built into Sonic Pi, and it's running this really cool visual synthesizer called Hydra, made by a really amazing lady called Olivia Jack. And she developed this. It's a JavaScript-based thing. It compiles down to GSL shaders and lets you generate cool stuff, cool pictures. This is like the background picture, and you can interact with the mouse. But I don't know if I still got an example here somewhere. No, let's code something up. So I can actually, if my web browser works, I can show you. I should have connection. There we are. This is the website you can go to actually explore Hydra directly. So there's a whole community of Hydra VJs using this software. It's super cool. And Olivia's amazing. You should support her project. And you can shuffle these around, changing all these cool visuals. So you find the one you like. Let's say which one do we like? This one's pretty cool. And then when I press close here, I can see the code that is used to make this visual. And I can go into Sonic Pi. I can write Hydra, copy that code in, and there is the same visual there, which is pretty fun. And so that's cool to think about what we can do with this. But the cool thing about working with the Erlang Elixir web technologies is they really are doing some really exciting futuristic stuff. So there's a framework called LiveView, Phoenix LiveView, which does some really cool stuff with pub/sub and WebSockets, which means that essentially for free, I was able to do this, which is to be able to open up another browser. So let's make this small so we can see this. And when I run the code, you can see it's changing it. But if let's make this a bit bigger. You can see I can actually now go to this code here. I can write OSC, do a very simple one, and run this code. And it immediately changes it, both in the browser built into Sonic Pi and my external Safari browser, or any browser connected to it with a WebSocket. So this is really an interesting opportunity, and this basically uses a pub/sub locally, so that when you change the code, it sees who's connected and forwards the new code to all the participating browsers. So this is going to be interesting to imagine performing at a venue that might have multiple big screens. You just say need to run a web browser on it, and as long as it's on the same network, I can control those different screens with lots of cool visuals. But it also means that you can start to think about doing live loops and changing this to different code. And now I have ability to alternate the codes as it's executing. So all the cool stuff I could do with the music, I can also do with the visuals, and I can do them in synchronization with each other. So I can do sample loop on min, on set pick, and maybe like this. Start to think about how you might synchronize the visual changes with the audio changes. Now, that's obviously a very, very simple thing I've just coded up in 2 seconds, but you can imagine what you could start to do if you experimented and played. And then you might be wondering what that little weird cube is spinning around the top left. That's something called processing.js, which is another really amazing piece of software for manipulating video. And so I wanted to make sure that I could get them both on the same web page at the same time, and you'll be able to code them both. So the GLSL shaders are for cool, crazy images, and the processing is for things like draw me a square, draw me a circle, draw me a picture, which may be a bit more the kind of thing, depending on the kind of creative output you want to be able to do. So to be able to work with them both together, and then to imagine any kind of web technology, be able to make a form with some sliders and dials, and you can start to tweak the control things there and experiment and create your own interface, DJ interface or VJ interface, and work with the two together. But anyway, yeah, so this is really all what I've been working on. I'm really all in pursuit of finding ways to engage that next generation of programmers through the ability to find ways to get artists to do credible artistic things. Because I don't think it's good enough often when you see educational software where they make things really, really simple so they can teach the curriculum, but that comes at a cost of it actually being useful in any kind of way. They'll hobble things down, make really simple, so that you can just get started. But then when the kids want to do something interesting, well, there's a glass ceiling there. So my goal has been to figure out how can we not have that glass ceiling? How can we make something that actually is credibly expressive and artistic, but also maintains that simplicity. So that's been my main challenge, is to figure out how to develop the software in a way that every single feature, be it concurrency or message passing across threads or deterministic randomization or lexical closures which do reverb and distortion, all of those things are simple enough for a 10-year-old child. And my challenge to you is, I'm sure your software is complicated and sophisticated, but not necessarily more than this. And could you teach a 10-year-old child how to use your software? And if not, then there's an opportunity for you to actually spend some time to think about how to simplify it, because when you do that, the benefits are way beyond getting 10-year-old kids to use it. It means that things are easier to work with, easier to onboard new people to your team, easier to debug, easier to figure out what the problems are. Like, the benefits are just wild if you can work with that. So that's my challenge, like gauntlet to you, like to try and figure out how to make your stuff as simple as possible. And really in the goal really is just to get out there, to be creative, to make the next generation of programmers, to get them to understand that code is creative, it's not just a business tool. And to really just get to be able to have people go to parties and say, I'm a programmer, and have that be an interesting thing, right? And it's like, before I used to lie, I used to say, I'm a musician. And they say, oh, cool. What do you play? Guitar? Saxophone? What? Code. Play code. And suddenly there's a conversation. So I think it's a really critical thing. So if you imagine going to a music festival, having never seen a guitar before, imagine how weird that is as an experience. Well, this is what we're bringing now to the next generation, where the new guitar is code. And when I say it's possible to build something that's both simple and sophisticated at the same time, and people go, that doesn't sound sensible, Sam. Well, that is what a guitar is. Anyone could pick up a guitar and strum the strings. So you can do the very simple stuff very easily. But also, there's Jimi Hendrix. And you're like, what is that? That's the possibility. I'm going to do that. So we should be building systems, I think, that have those properties, where it's really easy to onboard and get started, but there's a pathway to exciting opportunity of expression. Thank you very much. You're not working.